little bit yesterday, things we've done so far. Okay? You know what I mean. You guys still see your paper? All right, so we started off by talking about um, just matter in general, what makes up mass. What do you call mass? What is mass? Does it? Okay, number of particles that we show as dots. Okay? Matter itself, talk about matter, is really anything that has mass and takes up space. Anything that has mass and takes up space. So what we did this whole unit basically was talking about what mass was, takes up space, what that is, and then a relationship between the two. Okay? So the measurement that tells how much space something takes up is called what? Volume. All right, cool. Does that work? All right, it's important that we understand what units are used with each one. What do we use for mass? Grams. Okay? So talking about the actual measurements themselves. Mass, units are grams. And what kind of measuring device do we use to find the mass of something? You say balance? Okay? So we use those electronic balances, we put them on. Okay? People think of weight, similar to mass. Yeah, we don't have a lot of time. But we don't use weight, because weight depends on gravity. We want something that's specific wherever we are. So mass is in grams, we use a balance. What are units for volume? Okay, I heard milliliters, is that right? Okay. Cubic centimeters. All right, how do we find volume? Okay, so there's a couple different ways. That's why we have a couple different units here. All right. So for volume, if I'm doing milliliters, that's probably because I used a graduated cylinder, like I would use, say, if I was finding the volume of a liquid, or maybe I'm finding the volume of a solid using displacement. All right. What's the cubic centimeters for? Right. So when we do length in centimeters times width in centimeters times height in centimeters, that's going to equal volume in cubic centimeters. Centimeters cubed. All right. You guys should know the law of conservation of matter. Which means that matter cannot be created nor destroyed. So we showed our knowledge of this when we did modeling, when we did before and after pictures. So the before dots, particles, always had to equal the after dots. Okay? Before dots always equal after dots. If there was a middle or during picture in the model, that would also be equal to the other ones. What's that? Meaning they had no beginning or end? If we had 5 particles to start with, we can rearrange them, we can change them different ways, but we should still have 5 particles, 5 dots at the end, right? So we studied changes. Get what we actually called it, but we did a change lab. Remember that? And the idea of the change lab was supposed to be that we did different physical and chemical changes. And it was to show your understanding that the mass that we started with should have equaled the mass that we ended with, even though we made different changes. But that wasn't always the case. First of all, to talk about physical and chemical changes, physical change, that's just a change in size, shape, or phase. Or state for phase, whatever, solid, liquid, or gas. So when we melt something, we boil something, we freeze something. Chemical change, we make something new. But even in the case of a chemical change, all we're doing is rearranging the parts we started with. Okay, rearrange the parts we started with. So we make something new. It'd be like, here's something from your everyday life. When you guys rush home after school and grab your Legos, okay? And you have 10 Legos that are all separate laying there on the floor, and you want to build a tower, so you build one tall tower that is 10 Legos tall. You made something new. You made a Lego tower, but you still have the same number of pieces. You made something new, but you didn't like use new matter for it. It's not like it just appeared from nothing, from thin air, okay? And you could change that back again if you wanted. Maybe you want to make 2 towers that are only 5 Lego blocks tall. Again, you're starting with 10 Lego blocks, and you're making 2 5 Lego block tall towers. It's kind of hard to say. All right. Now, here's one thing we got to think about, though, that we didn't talk too much about. Systems. Okay? So make sure you're all paying attention to this. This is what it means. We can have open systems or closed systems. All right? So in the lab, the way we did it was there were a couple stations where the mass did change. And when we had discussions, we talked about it, we could make sense of that. Do you remember why? Maybe what stations involved a change? Anybody? Think back to that. Like the Alka-Seltzer, why would that be an acceptable change? Huh? Well, so that we saw gas bubbles produced, so we thought that was a chemical change probably. Okay? But where were the gas bubbles going? They were leaving, right? They were leaving the system. All right? So in a closed system, matter of any sort cannot enter or leave. So when we did that and we said, oh, the volume went, or I'm sorry, the mass went down, it decreased, does this make sense? Then we talked about it a while, like, yeah, because the gas that's being produced is leaving. So we measured this thing to start with, but since some of it was turned into gas, the gas left and we weren't able to keep it, all right? In an open system, which is what that would be, matter can leave and enter. Okay? We did another activity where we had some Bless you. Sorry, I can't draw very well, but let's say we had a container, all right, and we filled it up with a certain amount of water. Now, I should be doing dots here, right, but I'm just trying to be quick. All right, and what we did was, if I can make this, maybe I can make it 3D. So what we did in the lab was we did three sides. We did length, width, height. Okay, so here, here, and here, and we multiplied those three things together, and we got a volume in cubic centimeters. Let's say, just hypothetically, my sides on this were 2 and 5 and 10 centimeters each. If I multiply those three numbers together, I would get 100 cubic centimeters, okay? And then we took that same amount of water and we put it into a graduated cylinder. And so what we should have saw is that in the graduated cylinder there, this measurement should have been about the same. And this tells us, when we did our graph and found that slope, that the relationship between milliliters and cubic centimeters was a one-to-one relationship. Okay? Milliliters and cubic centimeters, one-to-one relationship. And then we did graphs. We did graphs of mass versus volume. Almost done. Not that I have a choice because the bell's going to be ringing. Okay? So we did dots. We made a best fit line through the middle of it. And then we found the slope. Okay? Finding the slope, we picked two dots that were easy to read on this line. Okay, we call the one that's more to the left x1 and y1. And then we found another one that was more to the right on the line. We call that x2 and y2. All right, so the x always first. For the slope, we do y2 minus y1 over x2 minus x1. And that slope, in this case, since it's between grams and milliliters, the slope would be telling us the grams per milliliter, which is density. Okay? We should know that density equals mass divided by volume. Mass in grams. Volume could be in milliliters or cubic centimeters. So our units for density will be grams per milliliter or grams per cubic centimeter. You should be able to figure out the density based on the slope, the rise over the run. You should also be able to figure out density from the formula. You should be able to switch those around and find the other variables. So if D equals M over V and I want to solve for M, what I'm going to do is multiply both sides by V and I'm going to get mass equals volume times density. All right? If I wanted to find volume, I would multiply both sides by V and then divide by D and I would get mass over the density. Okay? We should also know what density means in terms of floating. Less dense substance floats on more dense. All right? And that's pretty much everything. Be able to draw your models, show conservation of matter always, make your dots in your models. Don't be coloring things in. At this point, if I'm still seeing no dots in models, I'm going to rip all my hair out. Okay?